Dear student, we are going to study a topic or representation of three dimensional molecules. There are various methods which have been developed for two-dimensional representation of three-dimensional structure. First one is known as the flying wedge representation. In this, how we represent a molecule, for example, we have a compound like this carbon which is attached to a aldehydic group and alcoholic group, and CH2OH group is attached like this bond, and the another hydrogen is attached with the dashed lines. In this type of structure, we have three types of bonds or the lines. First one is a solid wedge. Solid wedge, to which we can say it is a thick line. It represents a bond projecting above the plane of the paper. Means this CH2OH group is above this plane of paper towards the viewer side. And the next one is continuous lines, normal bonds, to which CHO and OH groups are attached to this carbon. These are known as solid lines. These two bonds are present on this plane of paper, while the third one is a broken wedge. Broken wedge or dashed lines. These lines show a bond, means this hydrogen is present below the plane of the paper. This type of representation is known as the flying wedge representation. The second type of representation is known as Fisher second type of the representation is known as Fisher projection formula. In this, the structure is given like this. This is the chiral carbon, and the four different groups which are attached to this chiral carbon are CHO, OH, CH2OH and H. This is the Fisher projection formula. In this projection, all the bonds are drawn as solid lines with the understanding that horizontal bonds means this one and this one. These two bonds are known as horizontal bonds. These horizontal bonds point towards observer, जो देख रहा है above the plane of paper, above the plane of paper, and these two bonds are vertical. Vertical bonds. Vertical bonds are pointed away from the observer, to which we can say these bonds are present below the plane of paper. Below the plane of paper, to which you can see like this. In this structure molecule, this is the molecule where it is the centrally carbon, which is chiral carbon. Four groups are attached, and we can see these two bonds, means hydrogen and hydroxyl groups, are attached to this chiral carbon. These two bonds are known as horizontal bonds, and these are above the plane of the paper, while these two vertical bonds are below the plane of the paper. Usually, the Fisher projection is drawn in such a way that the longest carbon chain in the molecule is vertical with the highly oxidized function at the top. Now, the point which we want to discuss, that in order to find out whether the two structures are identical or not, we have two types of structure, and we have to find these two structures are same or not. How we can identify these things, to which we have some rules. There are some rules which must be obeyed. First point, for the purpose of comparison, a Fisher projection may be rotated 180 degree in the plane of the paper. This gives the equivalent structure. Mind it, a Fisher projection may be rotated 180 degree in the plane of the paper. This gives the equivalent structure, and it can be understood with the help of this example. As we have this chiral carbon, there are four different groups, and if we rotate the molecule through 180 degree, means this CHO will come to this position, and this CH2OH group will come to this position. Similarly, at the same time, OH group will come to this point, and this hydrogen will come this point, and we will have the structure like this. CH2OH is here, CHO is here, H is here, and OH is here. By rotating the molecule by 180 degree, the compound second we have, it is the same as it is the first compound. And next thing, two or any even number of interchange of the ligands, means the groups which are present, two or any other even number of interchange of the ligands at one chiral center does not change the configuration. How we can understand this point? Take this one example. Carbon, this is the chiral carbon. These are the four different groups or the atoms which are attached to this chiral carbon. Now we will take the first interchange between any two groups. We will take any two groups and we will interchange this. What? For example, we have taken here OH and CHO. We have taken this OH and CHO. They will mutually replace their position. So after doing this, we will have OH here and CHO here. H and CH2 OH groups are same as they were earlier. Now it is the first interchange. When we will take the second interchange, in which The remaining groups or the atoms means hydrogen and CH2OH will be replaced with their positions. There is the interchange. In this way, CH2OH group will come to this position and this hydrogen will come to this position, and after doing this second interchange we will get this structure like this. CH2OH will come here and H will come here. So after two interchanges, whatever the structure we are getting here, it is the same as it was earlier. Means if we make two interchanges in a molecule, we will get the same molecule. Next point is one interchange. Means as we have considered here two interchanges, and after two interchanges we same molecule. If we make only the first only one interchange in the molecule, we invert the molecule. Means if the molecule is R glyceraldehyde, it will be S glyceraldehyde. The configuration is inverted, different. And what is R configuration and what is S configuration, it will be discussed later. Now next point is a 90-degree rotation of the projection about the chiral center inverts the configuration in the same way as one interchange of the legions. What it says like this: we have the same molecule R glyceraldehyde, CHOOH, CH2OH and H. These are the four different groups which are attached to this chiral carbon. And if we rotate the molecule by 90-degree, means this CHO will come to this position, this OH will come to this position, and this CH2OH will come to this hydrogen will come to this position. We will have the structure like this. And if we rotate the molecule by 90-degree, we will have the molecule which is actually inverted, as in the case of one interchange what we have done here. Now next point is Fisher projection can be manipulated by rotating a group of any three ligands. Now as we have four groups which are attached to the carbon, now any three groups we can choose, one can be left, and after taking these three, for example we have taken here these three, CH2OH, hydrogen and OH. When these three groups have been taken and the position of these three atoms or the groups are interchanged either clockwise or anti-clockwise direction, for example we have taken here clockwise rotation, so we will get here CHO, H will come here, OH is coming here, CH2OH is coming here. Now whatever the structure we are getting, it is the same as it was here. Similarly, now we are taking these three atoms and we are leaving this OH. Now we can rotate the position of these groups or the atoms anti-clockwise direction, leaving this fourth separate. What we will get? CH2OH will come here, H will come here, and this CHO will come here. So whatever the structure we are getting here, it is also the same structure as it was earlier. Okay. Now the third presentation is the Sawhorse formula. Sawhorse formula. It is actually can be understand with a thing. For example, we have an example of ethane, CH3CH3. So this CH3CH3 ethane can be written like this. Okay. Now this carbon single bond carbon single bond carbon is taken as diagonally, and you can understand if it is taken as C1 and it is C2 and it is your C1, it is your C2. Now on C1 there are three hydrogen atoms. They can be like this, means each hydrogen atom is making the angle of 120 degree with each other, and the carbon 2 has also three hydrogen atoms and these are present like this, H H H. Again there is the angle is 120 degree. Now there is another situation which can be represented like this, as here we have taken three hydrogens like this bond is taken vertical upward. For example, we have taken here this bond vertical, similarly this vertical bond is there. Okay, now at this particular structure on carbon 1 C1 we have vertical upward hydrogen. In C2, this is actually the C2, we have vertical downward hydrogen. Now making 120 degree angle, we have these another two hydrogen atoms on this. Now there are two types of structure. This one, first compound, is actually known as eclipsed form, and this one is known as staggered form or anti form. Okay, this type of representation is known as Sahor's presentation. Next one is Newman projection. Newman projection. In this, there are two carbon atoms which are considered as front carbon is taken as a point while the rear carbon is taken as this circle. Now the carbon 1, which is represented as a point here, the three hydrogen atoms are like this, making 120 degree with each other, and it can be compared with this eclipsed form in such a way that the rear carbon also have the hydrogen atoms which are exactly the bond same, exactly, you can say, which is superimposing this particular hydrogen like this and like this. So this particular form is known as eclipsed form, and the another form is like this. It can be compared with this structure. The front carbon have three hydrogen atoms like this, making the angle 120 degree, while the rear carbon C2, will have the hydrogens like this. And if we compare the hydrogen, any hydrogen of the carbon 1 with the hydrogen of the carbon 2, it makes an angle of 60 degree, and this particular angle is known as dihedral angle. Okay, so this one is known as Sahor's presentation, while this one is known as Newman projection. Okay, thank you.